Lesson 20, Precalculus Larson. This is Chapter 3, Exponential and Logarithmic Functions. This lesson will help you understand how to solve simple exponential and logarithmic equations and more complicated exponential and logarithmic equations. Recall from our last lesson we did something simple. 4 to the x equals 1/16. What is x? Well, I taught you what you want to do is get to the same base. That same base could either be the number 4 or the number 2. We'll go with 2 to make it a little bit more fun. So 4 is the same thing as 2 squared to the x. And then 1/16, that's 2 to the 4th, and you're going to float it up. So it'd be 2 to the negative 4 is 1/16. So now we have the same base for both, which was 2. So we can set the exponents equal. 2x equals -4. So it gave us the answer of -2 because they were the same base. So that's the first property that we're going to use today. They call it in this section the one-to-one property. If you have the same base, you can set the exponents equal. Likewise, if you're taking the log to the same base, you can set what you're taking the log of equal and just solve that. And then the inverse property, notice there's an a there and an a there. If there's an a in both places of a log of x, it's just x. Likewise, if you have an a and an a to the x, then it's just x. Or like some of the students like to say, you pull the x in front, and then you have the log of a to the base a, which is just 1. So it's just x. All right. So doing a little more complicated exponent here, we have 1,000 times e to the -4x equals 75. What I like to say the steps on this is that first you isolate to solve all the equations today that we're doing. First you're going to isolate. We're going to isolate the exponent here, the chunk that has the exponent in it. And then after you isolate that, what you want to do is we're going to take the natural log of both sides. Yes, you could do the log or the natural log, but just to keep it easy, let's just do the natural log of both sides. So this chunk right here has the x on it. We want to solve for that chunk. We want to get it by itself. Just like you get absolute value by itself, and then you make two equations, one positive, one negative. Or we also, when you had a square root, you isolated that, and after you isolated the square root, then you squared both sides. It's the same idea here. We want to get that by itself. So get rid of the 1,000, so divide by 1,000. So that would make e to the -4x equals 75 over 1,000. And then what we do, now that we have it isolated, the exponent all by itself, we're going to take the natural log of both sides. And the natural log is really what you need to do on this one because of the letter e. So take the natural log of both sides. Just like I divided both sides of the equation by 1,000, I'm allowed to also just take the natural log of both sides. Why not? So natural log e to the -4x equals the natural log of 75 over 1,000. So I'm doing the natural log of both sides. So by the power property that we learned yesterday, you can pull this in the front. So that would give you the -4x natural log of e equals the natural log of 75 over 1,000. And the natural log of e we learned yesterday is just the number 1 because it's the natural log e and it's got a base on it of e. We don't write the e. And so since it's the same thing, it's just the number 1. All right, so that's 1. So then you have -4x equals, I want to clean that up. We can divide them both by 25, which makes, I think, 3 over 40. Oh, let me double check. So 75 divided by 1,000. Hit math, enter, enter. It's 3 over 40. All right. So it equals 3 over 40. And then I'm going to get rid of the -4. Oh, wait a minute. I lost the natural log of it. Well, it's a sad story. So we got -4x equals the natural log of 3 over 40. And then you want to get rid of the -4. So I'm going to multiply by 1/4, -1/4 times both sides. So the whole answer, the exact answer on it then is negative 1/4 natural log of 3/40. And if you put that in your calculator, you're going to get the answer about 0.648. Let's do that together. So negative 1/4, negative 1 divided by 4, parentheses, natural log of 3 divided by 40, close my parentheses, and you get 0.648. You got to round the 7 up to an 8 because the number after it was 5 or more. So the directions said the 3 decimal places, so that would be the answer. That's the exact answer. That's the rounded answer like they asked for, to 3 decimal places. On the next page, we're going to do another one just like this. We want to isolate the exponent here on the first one. The x is right inside here, so let's get that by itself. So subtract 15. So 2601 minus 15. And we get 2586. Then divide by the 6. And you get 8 to the negative 2 minus x equals 431. And then at this point, you could take the log or the natural log. On the last problem, it was a good idea to take the natural log because we wanted to cancel out the letter e. And if we didn't do the natural log, the e wouldn't have disappeared. We wouldn't have had the e to the base e, the natural log of e with the base e making the number 1 anyway. That had to be natural log. On this one, you could do natural log or log. So like I said, why not just keep it consistent and easy? Just take the natural log of both sides. So we're going to do the natural log of 8 to the negative 2 minus x equals the natural log of 431. And again, we're going to pull that power to the front then. So that would make negative 2 minus x, natural log of 8, equals the natural log of 431. So we have 2 chunks over here multiplied together. Resist the temptation to multiply across by the natural log of 8. You're just going to make a bigger mess. Get rid of that chunk here. Get rid of that whole chunk. So divide both sides by the natural log of 8. So that would leave then negative 2 minus x equals the natural log of 431 over the natural log of 8. And then move the minus 2 to the other side by adding 2. So plus 2. And then last of all, you have that negative on the x. So then x would equal negative of everything else. Natural log of 431 over natural log of 8 plus 2. And so that's kind of the exact answer. And if you put it in your calculator, you're going to get about negative 4.917. So I'll put it in the calculator for you real quick here. Negative, parenthesis, natural log of 431 divided by the natural log of 8, and then plus 2. So negative 4.917. All right, next one's really fun. If you look at it, you can see that it pops out and looks like a quadratic equation to you, but it's not a quadratic equation. But to make you feel happier and to understand a little bit about something that'll come later on in math class, let's call the middle term here u. Whatever's in the middle of it when it's funky and it's not the letter x, just call it u. So u is equal to e to the x. So that makes that u squared minus u minus 6 equals 0. It's u squared because if you put that e to the x back in here, I'll put it back in here. So u squared, if you put e to the x in for u, you would have e to the x squared, which makes e to the 2x. So you can just do that. So factoring this, that would give you u, let's see, minus 3, and then plus 2, u. All right, and then I was just doing that so it'd be cleaner for you to factor it so you can understand all we're doing is factoring. So we'll put the e to the x back in there then. So this e to the x minus 3 times e to the x plus 2 equals 0. So you could have just hopped to this step and not done that at all. I just was trying to help you. So e to the 2x is e to the x times e to the x. Adding up the middle and the outer term, it adds up to negative 1 e to the x, and then you got the minus 6. So I'm just trying to help you. It probably didn't help you, but I tried. So one of these two needs to be equal to 0. So set them both equal to 0. So that gives you e to the x equals 3 or e to the x equals negative 2. So then take the natural log of both sides because we have to solve it still. So we got another little math problem to do here. So natural log e to the x equals the natural log of 3. And again, pull the x out front. So then that just leaves x equals the natural log of 3. Then over here, it might not pop out at you for you to understand, but we can't get this ever to equal a negative number. So that's not a solution to it. But you might have persevered and tried to make it into a solution. So if you would have and taken the natural log of both sides, it would have given you the natural log of e to the x equals the natural log of negative 2. Pull the x out front. So you get x equals the natural log of negative 2. So if you would have tried to find an answer for that then, so we could do the answer for the natural log of 3. Natural log of 3 is 1.098 or 1.099. If you try to do the natural log of 2, it's going to say non-real answer on it. It doesn't have an answer. It's not because your calculator is broken. It's because you can't do it. So don't think your calculator is broke. It doesn't work. It's not a solution to it. All right, so on the next one, number 74. I don't know if you can see that it just pops right out on you. This is like the one I did when we started the notes. When we started the notes, I was telling you how you need to get to the same base. And when you get to the same base, you set the exponents equal by the one-to-one property. A to the x equals a to the y. Then x has to equal y. So they have that here. We have e. E is the same base. So we can just set the exponents equal. So 2 to the x equals x squared minus 8. Yes, you could have overachieved and done the natural log of both sides and then put those powers in front. And I don't know, it's not a big deal, but this saves a little bit of work. We've got another quadratic equation again. So remember, you need to solve it for 0. So I'm going to move the 2x over. So 0 equals x squared minus 2x minus 8. Factor it. So we get two answers, 4 and negative 2. And those can both, the negative 2 can be an answer. See, if you check it, so if you put the negative 2 back up into here and try to use it, it just doesn't work right there when you try to do the natural log of negative 2. It doesn't work, so it's not an answer. Here, when you put it back in, some people might be thinking, well, wait, it's negative, it doesn't work. It's okay, because it's a power. It's not that something we're trying to take a natural log of. It's a power to up there. So just to check it, you can put the negative 2 in. So that would make it e to the negative 4. And on this side, negative 2 squared is 4 minus 8. So it also makes the negative 4. So it checks. And you could check the 4 also, and you would have saw that it also works. But those are both answers. That's why I circled it. And here's the answer on that one and the answer on this one. All right. So the next one, we're going to cross multiply. We have a fraction. So let's make the other side a fraction by putting a 1 underneath it and then cross multiply. So we have 1,000 times 1 minus 2 to the e to the negative 1,000ths equals, multiplying the other way, you got 50. So then divide by the 1,000 because we got two chunks multiplied together. So let's clean it up here and get rid of that chunk by dividing by it. So then that gives you 1 minus 2e to the negative 0.001x equals 50 divided by 1,000. Let's live on the edge this time and just change it to a decimal. So 50 divided by 1,000 is 0.05 or 5/100. And then move the 1 over. So we're going to subtract 1. That gives you negative 0.95. Divide by the negative 2. And you get positive 0.475. And then last of all, you take that natural log of both sides. So the natural log of e to the negative 0.001x equals a natural log of 0.475. So then after that, move that power in front. So it'd be negative 0.001x, natural log of e, equals the natural log of 4.75. So that's gone. And so then you just need to divide by the negative 1,000ths. So then x equals, the exact answer would be this. And when you put that in your calculator, you're going to get 744.440. All right. Number 98. Now we're doing logs. All the other problems we did were exponents. Now we're doing logs. Look at that. It's got the same base. Since they have the same base, just set them equal. So 4 plus x equals 2x. Subtract the x. And we got the answer. We're done. It's 4. And it works. You can plug it in up here, and we're taking the log of positive numbers, so it's fine. That's the answer. Okay, the next one. Let's change this so that it has a power on it. So it's the natural log of x minus 8 to the 1/2. There's a little imaginary 2 here, just like there's an imaginary e there that we don't bother writing. So it's the square root, so the second power. So the square root of x minus 8 equals 5. What we're going to do is rewrite these as an exponent. So that was a rule that we learned in the last lesson. If you have maybe the log base 8 of x squared equals 6, you can rewrite that as 8 to the 6 equals x squared. Or let's do a different one. Maybe log base 3 to the 4th equals 81. So writing that again as an exponent, it'd be 3 to the 4th equals 81. That's really sloppy. Sorry about that. So the same thing here. I'm going to rewrite this as an exponent. There's a little e there, so it makes that e to the 5th equals x minus 8 to the 1/2. So next up, we need to square both sides to get rid of this. So square the 5 and square this. So it makes that e to the 10 equals x minus 8. And then move the minus 8 to the other side, so it makes it plus 8. So that's the exact answer. And if you put that in your calculator and you found the answer from that, you would get, let's see here, a big number. You would get 22,034 and 466 thousandths. All right, the next one also has the same basis, but no, you can't take the, be careful, it's got a plus sign on it. There's no rule for having a plus sign on two logs added together to just pop it out from there. You're going to have to use the rule from yesterday that when you add logs, you multiply them. So that makes it the log base 3 of x times x minus 8 equals 2. And now we're going to write it again as an exponent. So that makes 3 to the 2nd equals x times x minus 8. And 3 to the 2nd is 9. Multiply across by x, so that makes x squared minus 8x. Move the 9 over, so that makes x squared minus 8x minus 9. So again, you got a quadratic equation. That's why I solved it for 0. And I'm going to go ahead and factor it now. It factors in x minus 9 and x plus 1. So you got the answers a 9 and negative 1. So let's eyeball it here. Can it be 9? Sure. Could it be negative 1? No. We can't take the log of negative 1. It's not possible. If you try to do that in the calculator, it doesn't work. So the only answer here is 9. On the next page, sometimes you have one that's so hard that you can't just solve it. So what you're going to do is use the zero root property that says if you move everything to one side and make the other side 0, that you can just see where it crosses the x-axis at. So I'm going to move everything, I'm going to move that to the other side so it's minus, and put it in my calculator and see where it crosses the x-axis. So turn on the calculator here. So y equals, and putting it in there, you've got x minus 3 squared, and then minus log. It's to the base 10 already, so I don't need to put another 10 on it. That's what the base of log is. It's always 10. And then graph. And then you do second calculate the 0 and find those two zeros. So second calculate the 0. Pick a point to the left Where's the mouse? He's got to come back. There he is. So enter, and then go to the right, to the bottom of the hill past the 0. Enter again, and you get 2.385. And if you do that for the other one there, you're going to get the other 0 is, let me see here, 3.758. All right, so those would be the two answers to it. In case the video cuts me off, YouTube cuts you off after so many minutes, we can look at this in class tomorrow. But the last one, the real life problem, we want to use compound interest continuously, which a formula we had yesterday was PERT. And we want to know when the money doubles, and we're investing $1,000. So when does it double? That would be when the $1,000 becomes $2,000. And the interest rate was 6%, so 0.06. And we want to find the time. So divide by 1,000, you get 2. And then you got a little math problem to do, and you would take the natural log of both sides. And then move the power in front of it. So 0.06t natural log e. So that's gone. And so divide the natural log of 2 by 0.06, and you'd get the time is 11.55. Then they want to know when it triples. When it triples is when the 1,000 becomes 3,000, and you do the whole thing again. And then someone asked me about the next one here. What is that? Is a decimal. Move it over 2 places. It's 0.0375. All right, I'll see you tomorrow.